Hey guys, I'm Jay. Today is my LeetCode review vlog on the 56th problem, merge intervals. We are given an array of intervals, where intervals of I equals start to end. We have to merge all overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. Let's see example 1 here to understand it easily. We got the input intervals 1 to 3, 2 to 6, 8 to 10, and 15 to 18. And we can see that we can merge 1 to 3 and 2 to 6 to a one interval. So the final input is 1 to 6, 8 to 10, and 15 to 18. Next, let's get started with our introduction to solve the problem. We can handle this problem by two steps. And the first step is sorting. We can sort the intervals based on their starting values, and this would allow us to easily check for overlaps as we iterate through the sort list. And the second step is merge. When we traverse through the sorted intervals, then we can merge any overlapping intervals by updating the end of the current interval if necessary. Next, let's get started with a code to solve a problem and very detailed explanation. And the first step is we have to take care of those edge cases, and that is if intervals dot length is less than or equal to 1, then we just return the intervals itself. This is because the interval itself is already non-overlapping or just empty. So we just return it itself. And the second step is we have to sort the intervals by their starting points to ensure that any potential overlaps are contiguous in the array. And the code is we can use the utilities method, which is arrays.sort, and the first parameter is intervals. And the second parameter, we have to implement a comparator. And we have two number to compare, which is I1 and I2. And the rule is we can use the integer dot compare of I1 of 0 and I2 of 0, because we have to compare their starting point. And next, we have to create an array list to store the merged intervals. List of list array. Let's call it results and assign a new empty array list. Next, we'll create a new interval. So far, int array to store the interval we'll check during the iteration. Let's call it int array new interval, and we assign the first interval to it, interval of 0. And we have to create another, we can add the new interval into the result list. And then we have to create an enhanced for loop to iterate through the intervals. And for each interval, its type is int array, and let's call it each interval as interval. Then a column and intervals for each single interval. We have to check if there is an overlap between between the corresponding interval and the new interval we created before. So the code is if interval of 0, which is the start point, is less than or equal to the end point of new interval of 1. If so, which means there is an overlap between them, so we have to merge them by updating the end of the current interval, which is new interval of I equals math.max of new interval. of 1 and interval of 1, 2, because we have to take a big one of the endpoints between them. And on the other situation, which means they are two disjoint intervals, so we have to add the new interval into the list. New interval equals interval. Next, we'll add it to the result list. New interval. And out of for loop, we just return the merged intervals, which is result. Return result to array of new int. And the first parameter is result.size. Then let's check the correctness and analyze the time and space complexity. So the time complexity, it is big O of n times log n. Oops, I got something wrong here. I have to correct it. It's on line 4. And let's check it again. So for the time complexity, it is big O of n times log n. Interval on line 7. Big O of n times log n, and n stands for the number of intervals. This is because, yes, our code got accepted. Big O of n times log n. This is because we use a quick sort algorithm to sort all the intervals, which takes n times log n, time complexity, and then the merging process takes big O of n as each interval is processed once. So the overall time complexity is big O of n times log n. And for the space complexity, it is big O of n, because in the worst case, we will store each interval into the result list. And thank you guys for watching on my LeetCode review vlog on the merge intervals problem. And I really recommend you guys to visit my online GitHub page here. You can see all the notes and the problem description, the intuition, Java code with very detailed explanation, and the final time and space complexity analysis. For example, for the merge intervals problem, you can see problem description, intuition, Java code, explanation, and the final time complexity analysis. You can also visit my GitHub repository here, which contains the code and notes to build the online GitHub page. And I'll put those two links on my YouTube description below. And thank you guys for your watching. I'll see you next time.